Hello and welcome to this lesson of 3D modeling for 3D printing. I am Terrence King. In this lesson I will be covering the Subdivision Surface Modifier. In order to get to that, you find our tool shelf up here, find the wrench, add modifier, Subdivision Surface. Now I'm starting out with my little 2mm by 2mm by 2mm cube, and go ahead and add that modifier. Let's go ahead and take a look over here. How many subdivisions do you want? So right now I've only got one subdivision, so that divided all the faces. It actually, let's go ahead and tab into our edit mode, and if you look over here at this face, right now this face is actually 4 sections. So all that did was create an edge loop here and an edge loop there, and then smooth all the surface around it. So if we increase that number, views, two subdivisions, so now we can count those 1, 2, 3, 4 by 1, 2, 3, 4. So that's 16 sections. So if we add our edge loop right here, then we can see that it is 2 up top and 2 on the bottom and 2 in either direction. So it's exponential each time that you do that. It actually splits it up again and then splits it up again. Now the higher the number I increase for my subdivisions, it's actually becoming more and more like a sphere. Now let's go ahead and add a sphere to this mesh UV sphere, and let's compare the two objects. So with this sphere, let's go ahead and tab into edit mode, and all this is concentric circles in either direction. So this the vertical circles are actually going around, rotating around that center axis point. This vertice and this vertice, and the rest of these just going around the sphere in a different level of the sphere. So let's go ahead and tab back out and look at this cube over here that we subdivided. Now we can actually see that it still has corners, but because the higher resolution that we are subdividing it with, the smoother it's going to look. Now let's look at the effects of what the subdivision modifier does. Let's go ahead and delete that and duplicate it and move it over here. Let's go ahead and remove that modifier, and we'll do the same thing to each one of them. So our cube we just made over here, tab into edit, select a face and extrude. Let's go ahead and pull it up, and that's all it did. It just made from a symmetrical box to a rectangular box. Now with the subdivision surface, let's go ahead and select that face, that same face, extrude. You notice that it is as nearly flat surface on the top now. Well, that is because we've got two edges right next to each other. If we pull that face away from it, let's go ahead and put it the same height as the other cube. So each edge within this mesh is deciding on where the angle is going to be. So let's say, for instance, we want to just go ahead and select all these edges right here. Now let's go ahead and drag those down, and you notice changing the orientation of it just because I'm moving that one edge. Well, why is that? It's because you're actually keeping your subdivisions within each face. If you look closely, this is actually following, this edge loop is actually following the edge loop that's already predetermined by the subdivision modifier. So those are the common edge loops. So the more I move this one, the more the other one moves. So it's just, as this face right here is shrinking, all the subdivisions within that face in here are also shrinking. Hopefully you're not too confused. Now, why do we want to know all this? It's so that we can have hard edges. Okay? So let's go ahead and put this close to center. We want a pill looking thing, but we're not trying to model the pill. We want actually some hard edges on that. We want hard edges with round corners. So let's go ahead and create our edge loop. Just adding that edge loop has even smoother surface. Let's go ahead and select these, scale in the Y direction, and scale them out. So that's nearly the same as keeping it the way it was. That just smoothed it out. So if I did the same thing in this direction and scaled in the X direction, oops, I'm getting my round sphere back again. Now I can keep doing this to each one of these edges and get finer and finer detail, but we're trying to keep this to where we're not trying not to add too much detail as it is. So let's go ahead and undo those. Now onto the hard edges. So what you noticed earlier is that as it was shrinking, as this edge loop was shrinking towards the top, that edge up here was getting a stronger, sharper edge in a flatter surface. So let's go ahead and add our edge loop and move it all the way over here to the side. It's actually touching. The more I move my cursor over, it's not going to go any further. That's as far as it can go. It's going to slide that way. Let's go ahead and hit enter. Add another one to the other side. Hit enter. So now we've got a harder edge and a flatter surface over here. Now we can, if you notice that we still have that rounded pill shape up here, that's because we haven't applied another edge loop across that. So we're adding more and more detail to this. So now if I rotate this on the x-axis 90 degrees, I get myself a toaster. But I have the nice rounded edge over here and a nice arc up and across the top. But let's go ahead and apply this. Now, what did that do? Well, those are all my normals. Let's go ahead and turn normals off. And let's zoom in down here at the bottom. Well, no matter how close I get it, I'm not going to have a true hard edge. I mean, technically in the 3D space, all the edges are hard edges, but whenever you're printing with plastic, it automatically smooths itself, except for by layers, and that's all about resolution, and that'll be explained later. But if you look over here, you know, down this side and up the other side, you can see that the transition isn't as much as this transition, but I'm still getting a arcing pattern through this side from the subdivision surface. So that's what the subdivision surface is for, is smooth surfaces where your hard surfaces used to be, where you want to smooth, say, if you're trying to 3D print a helmet, but if you extracted your file from a Pepcura file, then it's probably going to be low detail because nobody wants to do that much cutting and pasting. That it's going to be low detail, and that detail is actually going to be brought back using Bondo or Rondo or whatever combination of smoothing techniques that you might use. The whole purpose of this is to help you modify your files so that you don't have to do all that final prep work. You know, that's the advantage of having a 3D printer, is getting a final result. I mean, it's probably not going to be something that you want to make castings out of right away, but it is something that you want to do as little work on it as possible. You're going to be doing as much detail in the 3D file to get what you want your final product to look like. And this is really important, especially whenever you're scaling, because after you're adding layers of fiberglass resin or your Bondo or your combination of the two, called Rondo, that is going to create a thickness of the helmet, and it's going to add weight to it. Now, the advantage of the 3D printing is that you can keep it as thin as you can with still maintaining your strength behind it. And that's for all the people who are learning this for the purpose of 3D printing their armor. Okay, let's go ahead and go on to extracting Pepcura files.